My angels, welcome to Physics 11. I'm a math teacher by training. I started teaching here in 1997, but in 2002, the physics teacher that was here retired and nobody wanted the job, and they would have had to lay off a physics teacher. And I had a really good high school physics teacher. They would have to lay off a science teacher. So I took the job of teaching physics. And when I did that, my mom asked me, "What is physics?" Math, she knew what math was. It was counting and times tables and numbers and stuff. What the heck is physics? And many of you have signed up for physics and really aren't sure what it is. I'm going to give you the definition that one of my college profs gave me. I like it because it includes almost everything so that I can say almost everything is physics. He said that physics is the science of measurement. His argument was if you were measuring or calculating something, you were doing physics, which I like because that means almost everything is physics, and I'm kind of arrogant that way. But it also leads to a question. What do we measure? The big three that we're going to be doing mostly this year is distance, does anybody know what the SI standard unit for distance is? The SI is sort of what you think of as the metric system, except in science, it's the System International, because it's French, the standard international system. Yeah. Nope. Meters. Meters in Canada is actually spelled RE, but I tend to abbreviate, so we'll use a lowercase m from here on in. See how I did that? I tend to abbreviate. I even abbreviate. Nothing? Okay. Time. What do we measure time in under the SI system? Anybody know? You're right, I think. Seconds. Abbreviation for seconds is a lowercase s. I hate memorizing useless stuff, and I will not make you memorize useless stuff, but I'm going to tell you right now, it's really worth memorizing units, because often, if I do my job right, by the middle of this course, when you're solving, because physics is technically word problems, not the stupid ones they give you in math, word problems that are actually interesting. When you're reading them, you'll actually be scanning the questions for the units, and that'll tell you what everything is. You won't actually scan the question for numbers or information. Meters per second, that's a velocity. Meters per second squared, that's an acceleration. Newtons, there's a force. Good, I know where I'm going. So as much as I hate memorizing something, if I ever tell you something is worth memorizing, it's really worth memorizing. I would normally yell louder, but my doors are open. I don't want to scare the grade 8s across the hallway. Sorry. Third thing is mass. What are the SI units for mass? They should be grams. They should be. But unfortunately, a gram, the way it was defined, is just too small. So this is the only one that has a metric prefix in front of it, kilograms. The other ones, meters, not kilometers or decimeters or centimeters, not kiloseconds or milliseconds, seconds, but kilograms. In fact, in all of science, there are only 7 units that are defined. The rest are all based on those 7 units. So we already have length, which we said was meters. We already have time, which we said was seconds. And we already have mass, which we said was kilograms. Electric current is also a defined unit. Does anybody know the units for electric current? Volts is not. Volts is defined in terms of electric current, though. Amps. The next one is my favorite because I have a massive ego. Temperature is defined in degrees, except there is a specific temperature scale that is the SI standard, and it's not Celsius or Fahrenheit. What? My first name is Kelvin. My first name is actually an SI unit. I couldn't have planned that out any better if I'd tried. But yes, degrees Kelvin. This is a bit awkward. It's named after a mathematician named William Thomson, who was also Lord Kelvin, and he really knew his stuff when it came to heat, but he was so fantastically wrong about electricity that he set Britain's electric model back probably 20 years because he had a lot of clout and he was a bit of a jerk about wrecking people that disagreed with him, even though he was wrong. When the internet first became a thing, back around 1998, 1999, if you did a search for the word Kelvin, the first web page that came up under Google said, Kelvin is God. It was great. Sadly, that has vanished now, so I'm no longer God. Amount of a substance. This is one you'll see in chemistry, or if you've done Chem 11 already, you know this one as well. What do we measure the amount of a substance in chemistry? Mr. Perugia has one hanging from his ceiling. None of my grade 12s took chem last year. You measure it in moles. There's something you'll learn in chem called Avogadro's number, and okay. The last one is kind of neat because for the first 6, when you hear the name, you don't know how big it is. In other words, 1 second, unless you've been raised here, you don't know that 1 second is about that long. You have to have been taught that growing up. But this next one, as soon as I tell you the name, you'll instantly know how big one is. Does anybody know what we measure light intensity in? We measure light intensity in candles. And 1 candle is exactly as bright as all of you are thinking right now. Yes, that bright, which is kind of a nice unit. It's actually candelas, but it comes from the word candle. So abbreviation for that is CA. Having said that, you won't use any of those for this year. And in Physics 12, we'll do amps, assuming we're back to normal under the quarterly system. I don't know if I'll get to electricity and magnetism, but assuming we're back to our normal times, we will do electricity and magnetism, but we don't look at degrees Kelvin or mole as chemistry, and we don't look at candles. But those 7 are the SI 7 units. Every other unit that you've ever heard of, newtons, volts, joules, they're all based on these 7 definitions. Little physics humor, here's an easy way to compare temperature units. If you're on the Fahrenheit scale, 0 degrees Fahrenheit is really cold outside. 100 degrees Fahrenheit is really hot outside. On the Celsius scale, 0 degrees Celsius is fairly cold outside. 100 degrees Celsius, you're dead. On the Kelvin scale, 0 degrees Kelvin, you're dead. 100 degrees Kelvin, you're still dead, if you're looking for a way to keep track of things. What is 0 degrees Kelvin? There's another term you may have heard, a 2-word term that goes with it. Nick, what? What's meant by absolute 0? So you learn in Science 8 that what you think of as heat is actually particles jiggling. And as you cool things down, the jiggling gets less and less and less. So absolute 0 is when there's no motion. Now, ready for the weird part? Whenever we take the temperature of a substance, actually what we're taking is an average temperature of a substance. There's some that might be a bit hotter, and there's some that might be a bit colder. Okay, because not all the particles are uniform. We've gotten substances to just above absolute 0 and measured that. But what that really means, some of the particles are slightly above absolute 0, and some of the particles are, and we have no idea what that is or what that means, but it seems to be that there is something below absolute 0. We're just not quite sure what the physics of that would look like. Hashtag nerd trivia. Not on your test. If I ever give you nerd trivia, that's my way of saying not on your test, but I couldn't resist telling you. Turn the page. In addition to the base units, the SI, the System International, uses a prefix system to allow for the expression of large and small quantities. Prefixes can be placed in front of a base unit and they represent a multiplying factor. For example, 2.5 kilograms can be written as 2.5 times 10 to the third or times 1,000 kilogram, because the prefix kilo means multiply by 10 to the third or multiply by 1,000. Which is less writing, 10 to the third or 1,000? Which is less writing, using the exponents or writing all the zeros? Which method will I always choose to use? I tend to abbreviate, just letting you know. Okay? And you need to memorize all of these. No, you don't. I just told you I hate memorizing useless stuff that you can look up. Hey, look at your formula sheet. Flip the page over on the back page. Did I give you a big chart of all the metric prefixes? I think. Now, I'll tell you which ones are worth memorizing because you're going to get sick of looking them up, which is the only reason that you should memorize something, because you get sick of looking it up. But they're all there. So in the middle, we have our base units. So this is where we would put meters or seconds or joules or grams or volts or whatever unit, yontas, whatever units you're looking at. I don't know, yonta is a made-up unit, okay? If you want me to be fussy, that's technically being multiplied by a 10 to the 0, because Aiden, what's anything to the 0 power? Not, thank you, 0, okay? Going down, we're getting bigger. Going up, we're getting smaller. It's interesting, about 4 years ago, I used to stop here, and I used to stop here when I first started teaching physics. I'm slowly having to expand this as technology improves. So we're going to go up. Let's get smaller. Deci. What's the prefix on your green sheet for deci? What's the abbreviation? I know it's a D. Uppercase or lowercase, because it makes a difference. Lowercase d, that's it. And that's a 10 to the negative 1, or times by 0.1. Gotta be honest, I never use this one. I never say, oh, that's 3 decimeters. I say that's 0.3 meters, because that makes sense to me. What's the abbreviation for centi? And that's 10 to the negative 2, yes? Mr. Dewick, 10 to the negative 2 is 0.01. I thought you timesed by 100, because I thought 1 meter is 100 centimeters. You divide by 10 to the negative 2, and dividing by 10 to the negative 2 is the same as multiplying by 100. Centi I use once in a while. That's probably one that you have memorized just because you've had rulers growing up. Milli, what's the abbreviation for milli? Upper or lowercase? Problem. Here's the problem. How many letters do we have in our English alphabet? Not enough, because what's the abbreviation for meters? Lowercase. What's the abbreviation for milli? Lowercase. So if the lowercase m is in front of another letter, that's milli. If the lowercase m is after another letter, that's meters. And you're really going to like it when we get to N for newtons and N for north and N for normal force. Or when we get to W for work, for watts, and for west. We don't have enough letters, and so you'll kind of have to go with the context. Anyways, milli, 10 to the negative 3, yes? In other words, if I want, this would be, this would be millivolts. Okay? This would be centimeters. The metric prefixes go in front. We need more letters. In fact, every once in a while we're going to break out the Greek, because what letter does milli start out with? What letter does milli start with? So that would make a good abbreviation. What letter does micro start out with? We just used M. So what we pull out is a Greek letter M. That's called a mu. M-U, mu. What does a Greek cow say? Mew. What does a Greek cat say? Mew. There's all sorts of jokes. Okay? That's micro. You may have heard the term microcomputers. The reason they were called microcomputers is the chips at that time had reached the size where they were measured in micrometers, or micrometers is often how they said it in the industry. 10 to the negative 6? Yes? No, it's negative 6, I believe. That's 1/millionth of a meter, or a microsecond would be 1/millionth of a second. Then there's nano, lowercase n, 10 to the negative 9. I used to stop there. Then there's pico, which is lowercase p, and now you're noticing they go up by threes because every 3 digits in our numbering system, you've moved to a new set of numbers, whether it's thousands or millions or billions or trillions, and kind of the same way going backwards. So I think it's 10 to the negative 12, yes? Femto, 10 to the negative 15. Mr. Dewick, do they even use these? Later on, I will show you a video of a femto camera, a camera that can take video for 1 femtosecond, and it's fast enough you'll actually see a beam of light moving across the screen in slow motion. It's that fast. Oh, yes. And then atto, which is lowercase a, 10 to the negative 18. We might have to go smaller. There is, believe it or not, an international committee that decides on the names of these things. There's a procedure and a process, and so as technology moves either in the bigger or the smaller direction, if we need more metric prefixes, there's a committee that decides what the next prefix will be. Now we're going to get bigger. Deca. Upper or lower? Lowercase d, lowercase a. And that's times by 10 to the positive 1. Gotta be honest, I never use decameter. First of all, it sounds too much like decimeter if I don't pronounce things really carefully. But also, I've never said, oh, that building is 4 decameters tall. It's 40 meters tall. That just makes more sense to my brain. Hecto, lowercase h. And 10 squared. By the way, if you want to, the ones you're going to run into the most, you could put a star next to micro in the notes and a star next to milli in the notes. And centi. Those are ones, if you want to memorize, you can. You'll memorize micro in physics 12 because when we look at electricity, we measure charge in microcoulombs, and rather than look it up every time, you'll clue in whenever you see that little m, you just replace it with a 10 to the negative 6. You'll memorize it because you're lazy, which is the only reason you should memorize something. And you should probably know kilo, lowercase k. And that's times by 10 to the third, or 1,000. And then if you have computer technology, you might be more familiar with these next ones because they're often used in computer memory or computer storage. Mega. What's the abbrev? Uppercase M. Why uppercase? They thought of that. They figured uppercase would imply bigger, the lowercase would imply smaller. So that was clever of them. And that's times 1,000,000. I remember Mega Millions. There's that lottery, 10 to the 6th. So that's how I remember that mega is 10 to the 6th. My first ever hard drive was 8 megabytes. And I remember buying it and just thinking, how will I ever fill that up? I mean, my goodness, who on earth could ever fill up 8 megabytes of data? Yes, I'm that old. Then giga, which is capital G, yes? 10 to the 9th. So giga is 1 billion. I have a stupid way of remembering that. If you gave me $1 billion, I'd probably go giga. Go gaga. Anyways, that's my dumb way of remembering that one. Whatever works for you. Tera. And that's 10 to the... What comes after billion? Okay, that's a trillion bytes of storage on a hard drive. I have an external hard drive here that's normally sitting here. That's a 1 terabyte hard drive, but I put it somewhere smart during the pandemic. I put it into such smart storage that I can't remember where I put it. So I'm hoping at about 3 in the morning one night I'll wake up and that's where I put it. Now I remember. Peta, Google talks about having petabytes of data on their servers. So peta, capital P. Exa, capital E. 10 to the 18th. Put your pencils down, look up. There is a pattern to this that maybe you're not aware of. Starting right here with kilo, when we start going up by threes, okay? This is the first one where we go up by threes. This is the second one where we go up by threes. This is the third one when we go up by threes. Tera is the fourth one when we go up, you don't write this down, when we go up by threes, and that's where the name came from. Tetra means 4. They pulled out 1 letter, tera. What does penta mean? They pulled out the N, peta. Some of you are going, wow, I never saw that pattern before. What's the prefix for a 6-sided shape? Hexagon. They pulled out the H, hexa. Okay. What's the prefix for a 7-sided shape? Probably SEPT. So it might be a seta. It might be an epta. I don't know if they've defined that one yet. Okay. Octa. So might be an otta. We'll see. But that's kind of where those names are coming from. They take the Latin numerical prefix, yank out a letter, and now it's a metric prefix. Hashtag nerd trivia. Any base unit can be used with a prefix. For example, 1 kilogram, you replace the kilo with a 10 to the third or 1,000 grams. 100 centimeters, you multiply 100 by 10 to the negative 2, 1 meter. Multiplied by 0.01. That's why I gave you the multiplication factors, not the dividing factors. We're going to do next lesson, or actually the third lesson, a lesson on unit analysis. I am happy if I have a one-size-fits-all method to convert from one unit to another unit. I'm good with that. And that's what I'm going to give you. It's not the easiest unit conversion method, but it is the best. In fact, I solved a second-year calculus question in 7 steps because I forgot how to do the derivative method, which would have done it in 2 lines. But I built a 7-factor chain and got the question right, and my prof was like, there's a shorter way. I know, I couldn't remember. But I was able to hopscotch my way there by doing unit analysis. Put your pencils down. Look up.